All right, now we'll actually take the notes on chemical and physical change demos another day. We're not really taking notes today, but this will be some good demos to refer to when we do those notes. But you got a good idea what a chemical change is. A chemical change is producing a new chemical. You're changing the chemical composition of something. So we're going to go through this list here. But here's really what you're looking for. Pieces of evidence that would indicate a chemical change. If something's bubbling, that is making a new chemical. That's making a gas. Bubbling would be a gas. Color change, I'm going to say usually, is a sign of a chemical change. Production of light, odor, heat. A lot of these would be associated with anything burning. That's clearly a chemical change. Something's burning. And formation of a precipitate, which is kind of a neat thing, is when you have two liquids and you mix them together and they combine to make a solid. Now you can't always tell right off the bat, but it's little solid powdery particles floating around in the liquid, and that's called a precipitate. Don't confuse it with rain, not precipitation, but two liquids that make a solid is a precipitate, yeah. Here we go, change number 1. Very expensive, don't try this at home, a little bit dangerous. Here's a paper clip.
Oh my God.
Oh my God. Don't put your hand. Don't put your hand. Don't hurt your hand again.
Okay. Okay, I got it. I changed it. Chemical or physical change?
Physical.
Physical. So we're going to put a P. And what did I really change about it?
Shape.
Shape. Just write the word shape. All right. If you like that one, you're going to love this one.
No. No. Wait.
She's gone crazy. Oh, you're bad. Oh.
Have you ever noticed it's easier to rip paper straight in one direction rather than the other? Don't try that right now, but paper is made up of long molecules that are really aligned in a certain way. Don't try it right now. You can try it at home if you want. But it's easy to rip it one way and difficult to rip it the other way because you've got to sort of break around all those polymers. All right, anyway, I've changed the paper. Chemical or physical change? Physical. What did you write? Half? Okay, we go with the same idea, size or shape.
Oh, good. I've never seen something on fire.
Stop it!
Get it with fire! Fire alarm's going to go off in a minute.
Hope not. All right. I changed the paper now. Chemical or physical? Chemical. There's lots of reasons why we could put. What do you want to pick?
Brown.
Look at the top of your list there. Okay.
Heat. Odor. Heat.
Okay, we could go with odor. You could go with heat. You could go with light. You could go with color change. Now, I do realize that sometimes the evidence could mean either thing. So you just have to use the overwhelming evidence as to whether it's chemical or physical. All right, stretching your rubber band.
I think you got it that one too.
What if I... All right, stretching it. I changed it. Chemical or physical? Physical. All right, a weathered penny. Really, this is a penny we found outside. Here's pretty much a normal penny. There was a change that occurred to this penny. It is a chemical change. What would be our reasoning? No, it's not a precipitate. Color. Yeah, this is a color change. This is a sort of form of corrosion. Okay, so this is a color change. That's got to be chemical. All right, now let's say I take the same penny. Now here's where we need to be a little careful. If you had a hot enough flame, you actually could sort of break the copper casing that the zinc is in, and a little drop of zinc will pour out. But any color change?
Could you use a Bunsen burner?
Yeah, you could, and you might do that in your chemistry class, depending on your chemistry teacher. But I have changed it. I mean, I wouldn't want to touch it. But did I chemically change it? Is it not copper anymore? It's still copper. The atoms are moving faster. So this is one, again, where we got to be careful. Okay, there is a temperature change, but was it because of a chemical reaction involving the penny? No, it is still copper. So this is a physical change. And you can put temperature change.
No, that's the favorite.
No, oh, the next one's great too. You're going to love this one. Real dramatic. Here's sand and pebbles. We're going to do a mixture separation lab later as well. This is not what wire gauze is for, but it is today. Ta-da! Sand, pebbles. I changed it. Chemical or physical? Physical. I did not chemically change anything here. And this, yeah, let's go with location. I changed location, doesn't mean I changed the chemical composition. Silver nitrate and potassium iodide. Which may say KCl on your sheet, but we're going to use potassium iodide. I just got a little bit of it here, which I got to save. And silver nitrate is actually expensive. It does have silver atoms in it, which are somewhat rare. So here's some silver nitrate. Here's some Ki. They're both pretty much clear liquids. And
What happened to change color bubble?
kind of. What happened there?
Murky.
It got murky. What is that?
Some kind of tiny ball to like color.
Look on your list. This is the new one to us.
Precipitate.
This is a precipitate. Now, as far as right now, it looks a little cloudy. Here's the one I did yesterday. You can see, and I'll walk around, that the solid particles I've made have fallen to the bottom. So right now it looks just cloudy, but over time the solid would sort of separate out.
Can we close the blind?
No, I broke it. All right, here's a glow stick. Yeah, this is actually used for night fishing. Yeah. And it's glowing. Now, I understand the snapping and changing the size shape. That's the physical part. But I'm obviously referring to what's going on inside the plastic here. This is a chemical change. This is giving off light. This is chemoluminescence. Chemoluminescence. A chemical reaction that gives off light. And the way it works is there's a little bitty glass vial in there, actually filled with hydrogen peroxide. And you break that vial and it lets the chemicals mix.
What's the other chemical? Hydrogen peroxide, like
Some sort of fluorescent chemical. There's different dyes in there because there's different colors too, not just like the green. One more interesting point about chemoluminescence. Some, well, sort of as bioluminescence, some animals do this too. Some fish do it. Some worms, lightning bugs. So that's kind of interesting as well. All right, heating a marshmallow, my favorite one.
it won't burn. What other?
All right, heating a marshmallow, or in this case, burning a marshmallow. Chemical or physical change? So correct, Zach, a chemical change. Pick a reason. Good, heat or gas production or light, any of the above. Alka-Seltzer in water. Alka-Seltzer in water. It's medicine. What's it doing? Fizzing, bubbling, which means production of a gas, which means it's a chemical change. Very good. So put C and then I would just put gas. You can even hear it. Shh. Crushing a sugar cube. Here's a sugar cube. Anyone know what this equipment is called? Interesting guesses, but Bryson is correct. It is a mortar and pestle. This is the mortar, this is the pestle, sort of a symbol of pharmacy. And sometimes people have them in their kitchens too, if they want to like crush up their own herbs, parsley, whatever. But anyway, I can crush up the sugar. And I've changed it. Chemical or physical? Physical. Shape change. Good. We're down to ammonia, which is a cleaning product. Doesn't smell great. Never mix it with bleach. Whoops, that was the wrong cap. Shh. And an indicator called phenolphthalein. Chemical or physical? Chemical. Chemical. Why? Color.
Wait, so what was that?
Okay, one more time. This is ammonia, which is a base, and we'll talk about acids and bases later in the year. It can be canceled out, neutralized by an acid. Fortunately, I have some acid right here. I have some vinegar. What will happen to...
Clear or green?
So, phenolphthalein turns pink in a base only. If I cancel that base out with an acid, the pink goes away. But that is a chemical reaction. There's a chemical change. All right, so now I've got vinegar. And here's just a few chunks of magnesium metal. Just a few. You guys in the front, can you see what is happening? It's fizzing. This is actually very similar to the Alka-Seltzer in water. It's producing a gas. And over time, it will even get warm. So, chemical or physical? Chemical. Gas. All right, lead 2 nitrate and potassium iodide. One of my favorites. All right, here's the rest of my potassium iodide. And lead 2 nitrate, also a clear liquid. Clear liquid.
It's yellow. I hate yellow.
It looks like cherry.
It's yellow and cloudy. So this is chemical reaction, formation of precipitate. This would settle out eventually too, and you'd have sort of solid yellow particles at the bottom. All right, and then acetic acid and sodium bicarbonate. Do you know what those are fancy chemical names for?
Nope.
Some we've already used today. Acetic acid?
That's right?
That is vinegar. Very good. So what do you think sodium bicarbonate is?
Salt.
Not salt. Vinegar and salt? Come on. Baking soda. Thank you, Bailey.
Can we do something that blows up? Oh my gosh!
Chemical or physical? Chemical. Gas. And our last one, which has been sitting here for a few moments, ice melting. That's changing. Is that chemical or physical? Physical. Be careful because a lot of people get this one wrong. This is still H2O, whether it's a solid or liquid. That is a physical change. I want you to actually put not shape, but state. Change state. Or phase. Change in phase. Because you're changing from a solid to a liquid, but that's still a physical change. All right, we made it. I appreciate your attention. Bryson, make sure you do get these answers from somebody. Thank you for filming. I'll try to get this up. So, another topic, physical and chemical properties. We already sort of went over this a little bit in the physical and chemical change demos. So, you know, where we added chemicals and there was a color change, and I asked if that was a physical or chemical change. You say chemical, sort of what I'm talking about. But a physical property is really any characteristic that can be observed or measured without changing the composition, which is there are many physical properties. For example, whether or not something conducts electricity. Can I run electricity through these copper wires in the pencil sharpener and change the copper wires, or are they still copper wires? Okay, still copper wires. So whether or not something can conduct electricity is a physical property. Now, if I want to know if that piece of paper will burn in oxygen, and I light it on fire to see, and it does, its ability to burn, was that a chemical or physical property? Chemical, because in order to test that, I had to chemically change it. All right, so here's sort of a list of a bunch of physical properties. Density, change in state. Remember the ice melting from our list? It's still H2O, it's still water. It's just going from a solid to a liquid. So change in state is a physical property. Solubility, sort of just meaning dissolvability. If I dissolve sugar in water, I really still have sugar and I still have water. That is actually a physical change. So solutions do not chemically combine. It's not like the sugar bonded with the water. All right, one of my favorite words, viscosity. Measure of material's resistance to flow. So, mentioned down here at the bottom, we have some dense liquids. We have the honey and the syrup. Those would be very viscous materials. Viscous. So this is viscous. This is supposed to be like syrup. Water is not viscous. Water flows really easily. Very small molecules. They move over each other easily. So here's our viscosity demo. Ta-da. All right, so electrical conductivity, the one I just mentioned, also a physical property. What does it mean if something allows electricity to flow through it? It starts with a C. Metals are good electrical. Excellent. Conductors. The opposite of that?
Insulators.
Very good. So like rubber around the wires, or plastic would be a good insulator. Even some solutions, some liquid solutions, can conduct electricity, and the term for that is an electrolyte solution, and we'll see an example of that later in the year as well. But anything that has ions floating around in it is an electrolyte solution. Of course, I know I haven't gone over ions yet, but salt water is an example.
What about Powerade?
Powerade should work too. So this is really, this is like the light bulb and the battery thing you guys did in middle school, where you had the battery, the wires, hooked it up, light bulb turned on. Well, imagine you cut those wires and stuck the ends of the wires in salt water. Well, the light bulb actually still comes on. Salt water has these charged ions in it, so that allows a path for the electricity to flow. All right, so chemical properties. So the ability of a substance to undergo a change that will alter the composition. So we have capacity to oxidize as one example. What does oxidize? What element does that sound like? Oxygen. Capacity to oxidize means a substance could combine with oxygen to form a new compound. Combustibility is really a type of oxidation. What is, if something's combusting, what does that mean? Burning, good. Hence the fire there. If something is burning, that is a clear example of a chemical change. Having the ability to combust is a chemical property. Capacity to corrode. What does corrosion mean? Yeah, like rust, sort of breaking down, which also can be an example of oxidation, because rust needs to, rust happens with oxygen. What's something that speeds up rust? Water. Yep. Okay, so those were all some examples of chemical properties. Now, hold on. This one we got to handwrite somewhere off to the side.
Which one?
You have this in your lab notebook, but I really would like it to be in your notes. So maybe just at the very top of this paper you're on right now. Well, let's just put them in our notes too. Signs of. Signs of a chemical change. Do you remember from the demos we did what some of those signs were? Okay. And I'm actually not even going to write heat. I'm going to write temperature change in general, because some chemical reactions actually do get colder, like an instant ice pack. How do those work?
Shoot out.
Yeah, you got to like pop this bag inside the bag. That allows some chemicals to mix. Much like snapping a glow stick, you're allowing two chemicals to mix when you break that inner vial. But I'm just going to put temperature change. Whether hotter or colder. Don't confuse that, though, with me also like heating up the penny. Was the penny itself getting hotter or colder? Well, let me rephrase that. Was there a reaction happening to make the penny hotter or colder? No, it was because I was providing an external heat source. So a temperature change, like something gets hotter, that's just a physical change. The atoms are moving faster, but they were still copper atoms. But if the thing itself is getting hotter or getting colder, like the instant ice pack or something on fire, that's definitely a chemical change. All right, I heard someone say color change. Remember, that's sort of, usually. Okay, what else? Precipitate, yes. Keep going.
Production of light.
Light. I don't necessarily want to add size, because that's like if I cut something in half. Odor. There's one more I can think of. Gas, which would be like the bubbling. Bubbles equals gas. Those are probably the main signs right there.